In this video, we write a C program to print a Fibonacci series up to n terms. First of all, we see what is a Fibonacci series. A Fibonacci series starts with two values 0 and 1, and then the next value is calculated by adding previous two values. That means 0 plus 1, we get value 1. The next value is obtained by adding previous two values 1 plus 1, 2. The next value is obtained by adding 1 plus 2, 3. In this fashion, the Fibonacci series continues. And let us say we want to print only one term. If n value is equal to 1, then we get series only 0. If n value is equal to 2, then we print a series up to two terms 0 and 1. If n value is equal to 3, then the series will get 0, 1, 1. If we want to print only 4 terms, then we get values 0, 1, 1, 2. And if we want to print 5 terms, then we get the series 0, 1, 1, 2, 3. Likewise, we want to print values. This is the sample output here. If we give n value 20, then we are getting value 0, 1, 1 and so on, etc. Now we see the program here. Initially we are taking a Fibonacci function. The name of the function is Fibonacci and its return type is void. That means it is not returning any value, and it is taking 4 arguments here. 4 arguments are of type integer. In the main function, we are reading n value. If n value is equal to 1, that means only one term, then we are printing directly 0. If number of terms are 2, then we are printing 0 and 1. Otherwise, if the number of terms are greater than 2, then we are printing initially two terms 0 and 1, and then we are performing recursion, and then we are calling Fibonacci function printing from the third term. Why? Because already two terms are printed here, and then we are calling recursion, and then we are performing recursion starting from the third term, and also we are passing n value, as well as we are passing the Fibonacci series starting values 0 and 1. Coming to the Fibonacci function, in the Fibonacci function, we are receiving arguments in a, b, term and n. Then we are calculating c value. Then we are checking condition. If term value is less than or is equal to n, then we are printing c value. And again we are calling recursive function by passing arguments b, c, term plus 1, comma, n. Why we are doing term plus 1 here? Why? Because when one term is printed, then we are making preparation for the next term. In this fashion, this particular function will work. Next we see the logic part here. Now let us say we have given n value 4. Now this condition is failed. Why? Because 4 is not is equal to 1. Again 4 is not is equal to 2. Then we come to else part. Then in the else part, two values are printed, that is 0 and 1. We get output 0 and 1. Then we are calling Fibonacci function. We are calling Fibonacci function by passing arguments 0, 1, 3 and n. N value here is 4. Why we are starting from 3? Because already two values are printed, and then we want to print from third term. And we want to print the series from third term. Now here a value becomes 0. B value becomes 1, term value becomes 3, and n value becomes 4. Then we are calculating c value. C is equal to a plus b, 0 plus 1, that is c value gets 1. We are checking term value. Term value 3, 3 is less than or is equal to n, that is 4, that is correct. Then c value is printed. What is c value? 1, 1 is printed. Then again we are calling Fibonacci function by passing arguments b value. What is b value? 1. C value 1. Term plus 1. Term value is 3. Term plus 1 means we are passing 4, and n value is 4. And again Fibonacci function is called. A copy of the Fibonacci function is created. Now here a value becomes 1. B value becomes 1. Term value becomes 4. And n value becomes 4. Here also we are calculating a plus b. A plus b means 1 plus 1, 2. Now term value 4. 4 is less than or is equal to 4, which is correct. Again we print c value. What is c value? 2. Then again we are calling Fibonacci function with by passing arguments b. What is b value here? 1. What is c value? 2. What is term plus 1? Term value is 4. So term plus 1 means 5 and n value is 4. Again the Fibonacci function is called here. Here n value is 4. In this a value becomes 1, b value becomes 2 and term value becomes 5 and n value becomes 4. Here we are calculating c is equal to a plus b, 1 plus 2, that is 3. And here term is less than or is equal to n. Here term value is 5 and n value is 4. That means this condition is false. Why? Because 5 is not less than or is equal to 4. That means now the entire statement is not executed. Then the recursion process is stopped at this point of time. Then there will be no more recursive function calls. This function is not executed. As there are no more remaining statements here, then control is returned to its caller. This is the caller for this function. Here also there are no more functions after this particular statement. Again control is returned to this particular point. Here also there are no more statements that are there to be executed. Again the control returns to the main function. And here also there are no more statements to be executed after, and then main function is also closed. So that's why we got output 0, 1, 1, 2. Why? Because we have given n value 4. That's why only 4 terms are printed. Now we see the stack involvement here. Initially, now assume that in the main function we have given n value 6. Now assume that n value is 6. Then we are calling Fibonacci function. Fibonacci of 0, 1, 3, we want to start from third term. Why? Because 6 is greater than 2. Then it is calling Fibonacci function. And again Fibonacci of 0, 1, 3, 6. It is calling another Fibonacci function. Similarly, in this fashion we will get a different Fibonacci function calls. Now we will see how these are executed. Now assume that in this function n value is 6. Now it is calling, initially it is printing 0 and 1. We got output. Initially we got output 0 and 1. That means we want to print 6 terms. Now it is calling Fibonacci function. Fibonacci of, it is passing values 0, 1, 3 and 6. 3 means third term. And here a value becomes 0, b value is 1. And what is term value? 3 and n value 6. And here what is the condition? It is calculating c value. What is c value? A plus b, that is 0 plus 1, 1. And then it is checking condition. Term is less than or is equal to n. Here 3 is less than or is equal to 6, which is correct. And then it is printing c value. What is c value here? 1. And then it is calling Fibonacci function again by passing arguments b, c. What is b value here? B value is 1, c value is 1, and term plus 1. Term plus 1 means 3 plus 1, 4, and n value 6. Then again Fibonacci function is called. A copy of Fibonacci is created and it will be placed in the stack. And all these variables, they will occupy memory. Here a value is 1, b value 1, term value is 4, and n value is 6. And after calculating c value, c is equal to a plus b, that is 1 plus 1, 2. And then what is the condition here? Term is less than or is equal to 6. 4 is less than or is equal to 6, which is correct. Then we print c value, that is 2. Again we are calling Fibonacci function by passing arguments b. B value is 1, then c value, that is 2, then term plus 1, 4 plus 1, 5, and then n value. Again Fibonacci function is called. In this a value becomes 1, b is equal to 2, term is equal to 5, and n is equal to 6. Then we are calculating c value. C is equal to a plus b, that is 1 plus 2. Here what is the condition? Term is less than or is equal to n. 5 is less than or equal to 6, which is correct. Then we are printing 3 value, 3. Then again we are calling Fibonacci function with arguments b value 2, then c value 3, then term plus 1, 6, then n value, that is 6. Again Fibonacci function is called here 2, 3, 6, 6. Here a value is 2, b value is 3, and term value is 6, and n value is 6. Again we are calculating c value. C value is equal to 2 plus 3, 5. Here also condition, n value is, term value is less than or equal to n. 6 is less than or equal to 6, which is correct. Then we are printing c value, that is 5. Then again we are calling Fibonacci function, Fibonacci of b value, that is 3, and c value, that is 5, and term plus 1. Term plus 1 means 6 plus 1, 7, and finally n value. And the control comes here. Again another copy of function is created. In this, a value is 3, b value is 5, term value is 7, and n value is 6. Here also we will calculate c value. What is c value? C is equal to a plus b, 3 plus 5, 8. But here what is the condition? Term is less than or is equal to n. 7 is less than or is equal to 6. Is it correct? Now this is incorrect. Why? Because 7 is not less than or is equal to 6. That means at this point of time the recursion will be stopped and the control returns to this particular point. And again there are no more statements here. Control returns to its caller, and similarly control returns to its caller, and similarly control returns to its caller, and finally control moves to main function. As there are no more statements to be executed in the main function, again it will be removed from the stack. Now in this fashion, once the functions are completed, then they are removed from the stack in the last in first out order. That means whatever that is placed in the last, that will be removed first. Then fib of 2, 3, 6, 6 will be removed, and then fib of 1, 2, 5, 6 will be removed, and then fib of 1, 1, 4, 6, fib of 0, 1, 3, 6 will be removed. And finally, after the completion of main function and all of its related variables, etc., they will be removed from the stack. In this fashion, we can write a C program to print a Fibonacci series up to given number of terms.